This is obviously my router table. It's actually the side table of my table saw, and I use the fence for the table saw as my router table fence. It's a quick way to save space. That way I don't need an extra router table. But this video isn't about the fence, it's about the router, and specifically the router lift. The router that's in the table is currently a Freud 2¼ horsepower router that I bought back in 2007, about 18 years ago when we bought this house. The best part about this router is it has the ability to raise and lower from above the table. That's the main reason why I bought it. It also came with a plunge router base, but I've never used it for that since it's been installed in this table the whole time. Now, the reason that I'm talking about it is this router does have some problems. The router lift doesn't like to stay stable. It has just enough wobble so that the cut isn't perfectly straight, which has always bothered me, and I've always just kind of lived with it. Another problem is that the height is very difficult to adjust and stay steady. Sometimes during the cut, it will just suddenly drop, leaving me with a very uneven and pretty much ruined cut. So I've decided to build a new router lift. There are lots of DIY router lift videos on YouTube, and I've watched a bunch of them. I haven't really found an idea that I really like, so I'm going to try to come up with something myself. I don't have any plans yet, and I don't know if this is going to work yet, so this might or might not be the first video in a series of videos about how to build this lift. And if it turns out that this works, then I'll do my best to make a set of plans for it. I have 4 criteria for this project. It has to be cheap, it has to be stable, it has to be adjustable from above the table, and it has to use the existing router plate. Router plates aren't that expensive, they're about $25 or $30, but I'd really rather not have to buy another one. Now, before I get started, I obviously need to take this router out of the table, but if you're wondering what I meant when I said it wasn't stable, let me take you underneath and show you what I meant. Here's a view of the router from underneath, and as you can see, it is able to wiggle a little bit in this housing, and that wiggle is just enough to throw off the cuts. Now, one of the other nice things about this router is it has this little lever here which engages the spindle lock over here. The problem is, as you can see, the lever actually broke several years ago. I had to epoxy it. It's a miracle that that hasn't failed. The other problem is that that lever doesn't actually spin when I engage it from the top. So that makes that kind of useless. Now, I would like to use this same router for the new router lift, so I just need to take the router motor out of the housing, and there we go. This is the fine height adjustment here for when you're not using this router in a router table, but I won't need this anymore, so I'll remove it. All right, the easy part, the disassembly, is done. Now comes the hard part, which is figuring out what exactly I'm going to do from here. Now, in theory, a router lift should be pretty easy. It consists of only 3 parts. There's a carriage, which will actually hold the router motor. There's some kind of mechanism to raise and lower that carriage, and then there's a box to contain it all. Now, as usual, I'm going to go as cheap as possible, as long as it's still functional. I'm going to use plywood for hopefully all of the parts, except for the part where I raise and lower the carriage. I have an idea for that, and I think you're going to want to stick around because I haven't seen any other router lifts which use this mechanism. And it's going to be really cool if it works. All right, while the glue is drying on those pieces that will eventually become the carriage, this is the box that used to have the dust collection system for the router in my table. And this is going to give me a general idea of how big I'm going to want this contraption to be. and how high this is going to need to be raised. And based on this, I think it's only going to need to go up and down about 3 inches or so. So I do think the easiest solution is going to be sort of like the Shopsmith version. It's going to have a base of plywood, it's going to have 2 posts that come out, and it's going to have 2 slides that go up and down on those posts that are going to be attached to the carriage that holds the motor. I have all of this scrap plywood, so I may as well use it. This looks like it's about the right size. Yeah, I think that'll work just fine, but before I cut this to size, I need to actually make the carriage so that I know how big I need to make this. All right, let's measure this first. The motor is just shy of 3 3/4 inches, so I'll need to make that size cutout on the carriage. I have the pattern all drawn up on my glued up blanks for the carriage. You can see that I have it offset up this way because down here is going to be where the threaded rod is going to be for the lifting mechanism. I cut out this practice radius and it fits very, very nicely, so I'm going to cut this out on the bandsaw. All right, that's nice. It is a little bit snug on this side and a little bit loose on this side. You can see there's a little bit of a gap here, and that's actually good. That way, when I screw this piece to this piece on both sides, it'll actually snug the carriage up against the motor housing. I'm going to use these 2 M6 bolts to bolt these 2 pieces together, so I need to go to the bandsaw and remove these pieces to give me clearance to drive in those bolts. Okay, my goal was to drill just deep enough so that it would mark this bottom piece, because I'm going to need to drill a larger hole in those for these threaded inserts. And there are the marks, so I'll drill those out now on the drill press for these inserts. All right, let's do a little test to make sure that those holes line up. All right, that is going to work just fine. I just need to 3D print some knobs, so I'll do that next. Okay, those knobs are printed in exactly the size that I needed. So now the big test is to make sure that when these are tightened down, that this holds the router securely. And yep, that is very secure there. And if I ever need to remove it, I can just loosen the knobs and this will slide right out. The next thing I need to do is to cut notches on both sides that will hold the slides so that the carriage can go up and down, and I'll do that with my dado stack. With the notches cut, now I can work on making the runners that will be glued in here. I found these 2 scraps of white oak in my scrap bin. I'll need to thickness these down to the right thickness and then cut a V on the outside that will work as the runners. This scrap of white oak will need to be trimmed to size so that this V-shaped runner will slide in it. Now I'll set the blade to 45 degrees, cut out the V that will accept the runners, and then cut this piece in half. I think I'll use this scrap of white oak as the posts. I'll just split it in half this way and then joint the sides flat and then plane it to the final thickness. Next, I'll cut the post to length, and then I'll cut a groove that will accept these slides. Now, as this slides up and down, I need a way to adjust these slides in the post so that this slides up and down smoothly without binding, but tightly enough so that there isn't any play. So I'm going to drill some M6 holes on the top and the bottom. I'll put in some M6 inserts, and then I'll have a thumb screw on the outside that will push these rails out slightly to make that adjustment. Now I could use T-nuts or little set screws for this, but I use M6 threaded inserts because I found a bunch of them on AliExpress for really cheap. I think a 50 pack was about $1 or $2. Plus, I can find metric nuts and bolts at Harbor Freight, a variety pack, for about $5. Now I don't want to use a steel bolt in here because as it's coming through and pushing on the slide, it could cause a divot, even though this is white oak and fairly hard. So I 3D printed these bolts, which should be plenty strong, but much softer, so they won't harm the slides. Okay, all the parts I think are made, but I haven't started assembling them. Before I start putting all these pieces together, I need to figure out how I'm going to attach this to my router table. The solution that I've seen most often is just screwing the plate to the top of the posts. The problem with that is whenever you want to remove the router from the table, you have to take out the entire contraption because the plate is screwed to the posts. I think I have a better solution, so let me show you what I mean. When you take out the plate, hopefully you can see that my router table has these supports that run along the entire length of the table. They're just made of pine, so I would have to reinforce them, but my idea is to just bolt the posts into these supports on both sides. Of course, that is going to limit the size that this router lift can be, but I know the exact size that it is because I had my old router box screwed into those supports, so from here to here is 11 3/4 inches. The piece of plywood that I was going to use as a base is actually only about 11 1/2 inches, so I have this piece of plywood that someone gave me. I can't remember exactly where it came from, so I'll use this as the base. I'll just have to trim off all of these weird bits. I'll just use the old box as a template on the new base to show me exactly how wide it needs to be. So this is how it's going to look when it's all assembled. This will slide up and down on the slides like this, and I'll just have to trim off this part of the base. Now at this point, you should probably be wondering, well, Adam, what about the lift part of the router lift? Well, I'm going to get to that right now, but it's not exactly what I had in mind when I started this project. All of the homemade router lifts that I've seen on YouTube, with a few exceptions that are dramatically over-engineered, use something like this, a threaded rod, which is inserted into this part of the router lift, and it's screwed from above, either clockwise or counterclockwise, to raise and lower the lift. As you can see, I clearly bought all of the hardware, and it wasn't that expensive, only about $12 for the threaded rod, the washers, the nuts, and the coupling nut. But using a threaded rod doesn't have the cool factor, so while I was trying to fall asleep several nights ago, I had an idea for using a linear actuator. If you're wondering, well, what in the world is a linear actuator? It's this. It has a motor that lifts and lowers this rod, which is exactly what I need to do. It runs off of 12 volts, so I made this 12-volt battery pack out of 3 18650 lithium-ion cells and a few 3D printed parts, and it also came with this switch that I had to wire up. A linear actuator is usually used for power windows on boats and awnings and things like that. And this is what it looks like when it goes up and down. Now that has some cool factor. So I just need to figure out how to attach this to this and make the system work. I've been doing some experimentation, and the linear actuator came with these brackets to secure it at the bottom and the top. The bottom one is going to be fine. I can just bolt that to the plate, but the top bracket is not going to work because this doesn't come out far enough. This surface needs to be perpendicular to the plate. So I'm going to have to figure out a different way to secure this to this piece here. So this is going to be screwed to the actual lift, and that will go up and down to raise and lower the router. Well, off camera, and I made sure to do this off camera because I wasn't sure if it was going to work, I cut these two little pieces of plywood and drilled a hole and some counter bores in there to accept this M6 bolt. This will then go around the top of the actuator like this. I will screw this in, and then this will screw to the plate that will go up and down. And I think this is going to work fine. And here is the basic idea. This box will be screwed onto this plate, which will be screwed onto the actual lift. And as the actuator goes up, it will lift this plate, which will lift the lift. It's probably not the most elegant solution in the world, but I always go with whatever works. Well, I had this whole thing cobbled together. Nothing is actually glued up or screwed or anything. Everything is just sort of clamped to everything else. But I wanted to put this together to do a sort of a proof of concept to see if this will actually work. So let's give this a try. Well, I'm a little bit surprised that it actually works. Once I get this all glued and screwed together, it should take out pretty much all of the play, and it should be a whole lot more solid. I'm still a little bit worried that the linear actuator itself might have a little bit too much play, and if that's the case, that's not going to work out. If that happens, that's not the end of the world. I can always convert to the old-fashioned method of using the threaded rod, but let's put this thing together first and see how it actually works out. Hang on, not so fast. It actually doesn't work. Yeah, it goes up and down, but it's not as stable as it has to be. Let me bring you in close and show you what I mean. Unfortunately, there's just too much backwards and forwards rocking from this part of the mechanism back here, and that's just because of where the force is applied. It's applied too far back here, and it needs to be applied directly under the carriage. Now, I'm not ready to throw in the towel just yet. I'm going to try changing the design a little bit and see if I can get this to work. Well, I have tried doing some more tinkering, including putting the linear actuator directly under the carriage, and that hasn't worked either. Again, the problem is where the force is being applied. It's trying to apply it over here, which is trying to tilt everything over that way. So this design is unfortunately not going to work. I guess if I had paid more attention to physics in college, then I would have figured this out beforehand. So back to the drawing board. Now, I'm not ready to throw any of these parts away. I can still use them if I end up going with the threaded rod. But before I do that, there's one more thing I want to try. All right, that seems extremely promising, but I'm not ready to claim victory yet. But let me show you what's going on here. I realized that there was no reason for me to reinvent the wheel, or in this case, the box. This is the dust box that I had installed around my router before, and all I did was put a plate that was installed to the carriage here, and then I have these two blocks, which are spacers, and then these two pieces, which capture the plate to allow it to slide freely, but there's no play here. Now looking from above, I had the linear actuator installed directly underneath this plate, which is responsible for lifting up the entire carriage. So that seems like a very promising design. This is just a prototype, so I'm going to build a better box that's more sturdy, and we'll see if this works. I am rebuilding the box, but not the entire box, just the back of it. The linear actuator is going to be mounted down here. I have the carriage mounted to this plate, which is sliding between these two rails. These are made of pine, which are planed to just a touch thicker than this 3/4 inch plywood. That way I can screw these rails on here. That'll capture the plate and allow it to slide without binding. All right, that slides very easily, but unfortunately there is just a little bit of play, so I'm going to need to plane these rails down just a touch. All right, that slides much better, and now there is no play at all. I disassembled this briefly just so I could cut out this notch in this plate. The linear actuator is going to sit in that notch, and it's going to push the carriage up from this point here, and I'm just going to rely on gravity to bring it back down. Now I'm just going to sand that notch completely flush here so that the linear actuator is impacting these two surfaces at exactly the same place. To figure out where exactly on the bottom plate to install the linear actuator, this is as far up as the router is going to need to be, just enough so that the nut extends above the surface of the table. So the linear actuator has a travel distance of 4 inches. So if I move this down 4 inches, that is as far down as it will go. And now I can install the linear actuator here. All right, so far so good. Unfortunately, the linear actuator won't sit flush on the plate because it's not actually flat. It sticks out here at the base. So I cut this little scrap that'll go here to lift that part up, and I cut this little scrap that will be installed under the base, and I'll secure it with a bolt through there. Okay, I have it clamped to my table saw fence, so let's give this a shot. It works. Well, it does work very well, but I found that there is quite a bit of play where the carriage connects to the plate. What I'm going to do is make a dado in the plate that the carriage will fit into, and then I will glue and screw that in, and hopefully that will eliminate that play. All right, it's the next day. The glue is dry. I applied a good coating of this slip-it sliding compound to the whole sliding mechanism, and we're going to give this another try. That works perfectly. Well, I guess the next thing I'm going to do is reassemble the box and then try to reinforce it somehow to make sure that there's no racking and that it is as stable as possible. And then I'll need to figure out what to do about the top plate. I know at the beginning of the video I said this, and it has to use the existing router plate, but I don't think that's actually going to be either necessary or possible. because the router motor would have to come up precisely in the middle of this opening here, and I just don't think I'm quite that lucky. The reason that I wanted to reuse this insert is because I wanted to be able to reuse all of these holes, but since the insert is not going to actually be connected to the router lift, that's actually not necessary. And the main reason for using one of these phenolic or aluminum router plates is because there's usually a router that's screwed to the bottom of it. The weight of that router can pull down on it and cause the table to sag. And since this router lift is going to be installed to the structure of the table rather than to the plate, I'm not going to have that problem, and I can just use a sheet of 1/2-inch plywood. To prevent the box from racking one way or the other, ideally, I'd like to put a bottom on, but I can't do that because the router motor is going to be sticking out right here. But instead, this strap just screwed to the sides should really help. I have the box temporarily clamped from underneath, and it actually fits perfectly, which is a little bit surprising, but I'm really happy. I don't want to bolt it in quite yet. I'm going to put in 2 bolts, 2 on this side and 2 on this side, into the struts that run this way along the underside of the table. And the reason that I don't want to bolt it in quite yet is I need to make sure that the router lift is perfectly perpendicular to the surface of the table. So I'm just going to put in a couple of screws on either side and then install the motor and test it out. It is temporarily screwed in place. I have the motor mounted in there. It was actually surprisingly easy. I'm going to use the old plate temporarily, and hopefully we should see a router appearing right about now. That's so cool. Okay, so it is very cool that it actually goes up like it's supposed to, but 2 questions. First, is it actually stable? And yes, this is way more stable than the old router lift. The second question is it actually perpendicular to the table? So I'm going to install my biggest router bit and make sure that it is perpendicular. It is perfectly perpendicular this way, but it is just slightly off in this direction. It is tilted slightly that way, so I just need to tilt the box maybe a 1/2 degree towards me. Well, it's been a lot of tweaking and another 30 minutes later, but I now have all 4 bolts installed, and let's just make sure that it is still square in both directions. That's square, and that's square. Perfect. Well, the next order of business is the actual router plate, and now that I'm looking at this, it is off a little bit, maybe about 1/4 of an inch that way, but it's really not so bad. For most of my router bits, this is actually going to work fine, and for any of the larger ones, I can just remove that. So I might just use this plate, at least until it doesn't work anymore. And that leaves me with one final task, which is figuring out how to engage the spindle lock, which is a button that's down here. There are a couple options. I could remove this, remove that, and then put my finger back here, and that engages the spindle lock. That's not a whole lot of fun. I could do that, and the spindle lock is right here, and that's not terribly convenient either. Oh, and I also need to figure out where to put the battery pack and the switch. Right now they're just sitting on the floor. It is once again the next day, and I spent a good portion of last night trying to figure out how to engage the spindle lock from above. It's definitely not a necessary thing, but something that I would want to do. I figured out a kind of crude workaround, but I want something a little bit more elegant. But to do that, I think I'm going to need to make a new router plate. So I have my old router plate here. I have the rest of the scrap of 1/2-inch plywood that I used to make the back of the box. So I'll make a new router plate and we'll go from there. The way that I would normally do this is cut out the approximate shape on the plywood, then I would double stick tape the plate down to the plywood and run it along the router table with a flush trim bit. Well, of course, the problem is I don't have a router table at my disposal right now, so I'm going to really have to do it more by eye. I did just a bit of touch-up sanding along the sides here, and now that is a really, really nice fit. So now I just need to cut a rabbet along the underside all the way around so that it'll actually fit down into that insert. The depth of that inset is just over a quarter inch. This is 0.29 inches or about 7.3 millimeters. So that's the depth of the rabbet that I need to cut. And the width of the rabbet will be about a half an inch all the way around. The best part about having to make a rabbet is I get to use the new router lift for the first time. I'm going to install this half-inch bit with a depth of cut of 0.29 inches and a width of cut of half an inch. I inset the plate just slightly below the surface of the table on purpose. I'm going to use these little M3 screws as set screws in the corners to adjust them just in case there's any wood movement. I added a little auto body filler to the corners here just to strengthen them a little bit, and I'm going to add some super glue to the threads on the plywood here just to strengthen them also. This isn't a super high stress area, so I'm not really concerned, but couldn't hurt. The filler is dry. I have this all leveled out. The last thing I think that I need to do is cut a hole in the middle of the plate. To do that, I have this pilot bit installed in the router, so I'm going to lower it for now. Then I'm going to install the plate and raise this up with some weight on it so that the pilot bit pokes a hole directly where it needs to be. Might be a little hard to see, but that's the hole right there. I'm going to need to make removable and replaceable inserts like this. To do that, I'm going to need to route a circular inset so that the plates can slip in like that. You might get an idea of how many tries it took me to get this right, but this is what I'm going for. This inset here is 5.1 millimeters, which is the same thickness as this plywood that I'm going to use for the inserts. My biggest router bit is about 2 1/8 inches in diameter, which means I need the insert to be no more than about 2 1/4 inches. And then I need an overhang for the insert to fit in. So this is a 2 7/8 inch hole. I'm going to double stick tape that to the router plate that already has the center mark right there. And then I'll use a pattern bit set at 5.1 millimeters high. Sorry to use metric and SAE interchangeably, but I'll do that off camera now. All right, that inset is now routed, and using that center hole, I'll use a 2 1/4 inch Forstner bit to cut the through hole. Well, this is looking more and more like an actual router plate. I'm going to use this same template, which has the 2 7/8 inch hole, to make several inserts out of this scrap of plywood. I made 3 different size inserts for different size router bits. They all fit perfectly, and the only thing left to do is get this installed. Well, I know I said this was the last thing, but I do still want to come up with a mechanism for pushing in the spindle lock button, but I'll leave that for another time. Well, that was a really fun project. It took quite a bit longer than I thought because there were a bunch of different engineering type problems that I needed to figure out. A lot of them sort of kept me up at night, but I got them all figured out, except for that one with the spindle lock button. But like I said, I'll get that figured out another time. Wait, I figured it out. So again, the problem was to figure out how to push in the spindle lock button from above. I could have cut a slot in the router plate and then had a lever to sort of push it in, but that would have left an unsightly gash in the router plate, and I wanted something that was a little more elegant than that. Another option is to just drill a hole like this and then use something like this pencil to lever the spindle lock button. That would be functional, but again, not an ideal solution. But I finally figured out a solution, and that's to use a cam. A cam is something like this that spins around an offset hole rather than around its center. So as it's sitting in here, instead of spinning around its center, it would move around that way, putting pressure in this direction, and then it can be moved out of the way. And that would be a perfect solution. So I drilled out a 1/4-inch mortise in the cam, and I made this little piece that has a 1/4-inch stem and this 1/2-inch head. This goes through here, then a washer. The cam gets installed here, and it's secured with an M3 screw. So now when I install this, the cam will be out of the way of the pin, but when I rotate it from above, the cam will move into the pin, pushing it in and locking the spindle. And then I 3D printed this little knob with a pointer that has a 1/2-inch cutout on the bottom that fits around the head. Now you can see that the spindle is unlocked. When I turn this, the cam engages. Now it's locked. And then I unlock it like this, and the spindle is free. Well, that was a really fun but really long project. It took a lot longer than I thought it would, but in the end, it turned out awesome. It works absolutely perfectly, and I really could not be happier. I'm going to try to put a set of plans on my website. The link will be down in the description. It's going to be kind of specific for my table saw and my router. I don't know if it will actually translate to your equipment, so please make sure that you verify that before you start. I know this was a really long video, but I didn't intend to make it as a step-by-step tutorial. I intended it to be more of an inspiration for you to do something similar, to make a router lift like this, or just to figure out that you can actually overcome your problems if you give it enough time and thought. So I hope I inspired you to do a project like this. If I did, please let me know what you did down in the comments. Leaving comments is a huge help for a small channel like mine. I know it doesn't seem like a lot, but it is. Other ways that you can support the channel include hitting like and subscribing, and also sharing the video with a friend. There are a couple of other ways that you can support the channel too. Believe it or not, I have a merchandise store. You can buy a sticker or a mug or a t-shirt. If you want to buy a sticker for a couple dollars and put it up in your shop, that would be awesome. You could also buy a digital readout for a DW735 planer. The link for my Etsy store will be down in the description. As always, thank you very much for joining me. I sincerely appreciate it, especially if you've gotten this far in the video, and I hope to see you next time.